Yeah, good morning. Today we are going to see how to fit a binomial distribution for the given data and test the goodness of it with an example using chi-square distribution. Okay, start with the question. Fit a binomial distribution for the following data and test the goodness of it. Here we are going to use the chi-square test to test the goodness of it. The data is your x start from 0, 1, 2, 3, 4, 5, and 6, and their corresponding frequencies are denoted by f, 5, 18, 28, 12, 7, 6, 4. Okay. So this is your given question. Now, first we will find the mean for the given data. Okay. So mean start with the solution. The solution will consist of two parts. The first one fitting binomial distribution. Okay, we'll fit it now. For that we need the mean. Mean is equal to sigma fx divided by sigma f, so which is equal to 0 into 5 plus 1 into 18 plus 2 into 28 plus 3 into 12 plus 4 into 7 plus 6 into 4, sorry, 5 into 6 plus 6 into 4 divided by sigma f. So 5 plus 18 plus 28 plus 12 plus 7 plus 6 plus 4. So which is equal to 192 divided by 80. So this value will be is equal to 2.4. So we got mean is equal to 2.4. We know that in binomial distribution, mean is equal to n into p, so which is equal to 2.4. So here the small n will be equal to 6, So this is your small n, and the sum of the frequencies sigma f will denote your capital N. Okay. So n is equal to 6. Substituting, we get np is equal to 2.4. So this will implies p is equal to 2.4 divided by 6. So which is equal to 24 by 60. So 12 twos are 24 and 12 fives are 60. So we got the value of P is equal to 2 by 5, then and Q is equal to 1 minus P, which is equal to 1 minus 2 by 5, which is equal to 3 by 5. Then the corresponding binomial distribution is the corresponding binomial distribution is P of x is equal to x, which is equal to ncx p power x into q power x, sorry, q power n minus x, and n is equal to 0 1, sorry, x is equal to 0 1 2 3 up to n. So substituting the value of n and pq, we get the distribution will be p of x is equal to x will be is equal to 6cx, and p is 2 by 5 raised to the power x, and q is 3 by 5 raised to the power 6 minus x, and x values will be 0 1 2 3 4 5 and 6. Next, we need to find their expected frequencies, that is, expected frequencies, which is equal to n into p of x is equal to x. Here n is equal to sum of the frequencies, which is your 80 into 6cx into 2 by 5 raised to the power x into 3 by 5 raised to the power 6 minus x. X is equal to 0, 1, 2, 3, 4, 5 and 6. Now we will compute their expected frequencies. For x is equal to 0, we get 80 into 6c0, 2 by 5 raised to the power 0, 3 into 3 by 5 raised to the power 1, and this is equal to, we get 3.73. Using calculator we can able to find it. Next, for x is equal to 1, we get 80 into 6c1 into 2 by 5 raised to the power 1. Sorry, here it is 6. 2 by 5 raised to the power 1 into 3 by 5 raised to the power 5. If we use a calculator, the value will be 14.93. Next, for x is equal to 2, we get 80 into 6c2, 2 by 5 raised to the power 2 into 3 by 5 raised to the power 4. If you use the calculator for this one, the value will be 24.88, and then for x is equal to 3, 80 into 6c3 2 by 5 raised to the power 3 into 3 by 5 raised to the power 3, which is equal to 22.12. Next, for x is equal to 4, 80 into 6c4 2 by 5 raised to the power 4 into 3 by 5 raised to the power 2. If you use the calculator, you will get the value will be 11.06, and for x is equal to 5, we get 80 into 6c5 2 by 5 raised to the power 5, 3 by 5 raised to the power 1, so which is equal to 2.95. And finally, for x is equal to 6, we get 80 into 6c5 2 by 5 raised to the power 6 into 3 by 5 raised to the power 0, which is 0.33. Now for expected frequencies, we have to round it off. So if it is more than zero point 0.5, make it as round it up to add 1 to the integer part. So we will get this is approximately equal to 4, and 14.5 will be approximately equal to 15. 24.8 will be approximately equal to 25, and 22.1, so it is zero point 0.1, so we round it up to 22, and 11.06 round it up to 11, and then 2.95 we can round it up to 3, and 0.33 we round it up to 0, and the sum of the expected frequencies will be 80. We can check it. Okay. And now we'll write the thing, the values of x will be 0, 1, 2, 3, 4, 5, 6, and the given frequencies are called as observed frequencies. That is, given frequency is called also called as observed frequencies. Or given frequency f is 5, 18, 28, 12, 7, 6, 4, and the expected frequencies are 4, 15, 25, 22, 11, 3, and 0. Next, the second step, using chi-square test, we have to check the goodness of the fit. The use whether the expected frequencies and the observed frequencies are coincide. Okay, up to the 5% level of significance. So now we'll do that one. So for chi-square test, the frequencies should be greater than or equal to 10. Okay. First, it's write in a tabular form in the column wise. Here, the observed frequencies are OI. They are 5, 18, 28, 12, 7, 6, and 4. Their corresponding expected frequencies are 4, 15, 18, 28, 4, 15, 25. 4, 15, 25, 22, 11, 3, 0. We can cross check it. You move here, you'll get here. 4, 15, 25, 4, 15, 25, and then 22, 11, 3, and 0. 22, 11, 3, and 0. So in chi-square test, the frequencies are should be greater than or equal to 10. So we have to merge the frequency with the neighbor one. So we'll get here, and we have to merge these two things, and we have to merge these two things. And then if I merge here 6 plus 4, I will get 10, whereas if I merge 0 and 3, I will get just 3. Further, it is in single digits, so we have to make it more than 10. So again you have to club with the nearest frequency, which is 11, that is 14. So correspondingly, you have to merge it with the neighbor one. 6 plus 4, 10 plus 7, which becomes 17. And here it is 18 plus 15 will be 23. And here it has become 19. Now the new observed frequencies and expected frequencies are the OI will be 23, 28, 12, and then 17. Next, the expected frequency is EI or 19, 25, 22, and 14. Next, to apply the chi-square test, the calculated value for chi-square is the calculated value for chi-square is summation OI minus EI the whole square divided by EI. So here we need to compute these values. So they should be is equal to 23 minus 19 the whole square divided by the corresponding expected frequency will be 19 plus 28 minus 25 the whole square divided by 25 plus 12 minus 22 the whole square divided by 22 plus 17 minus 14 the whole square divided by 14. So 23 minus 19 will be 4. So it is 16. Square is 16 by 19 plus 28 minus 25 will be 3. Square is 9 by 25 plus 12 minus 22 is 10. Square is 100 by 22 plus 17 minus 14 will be 3. Square is 9 by 14, and use your calculator and sum it up. The values will be 6.39. So we got that the calculated value for chi-square is equal to 6.39. Next we have to find the table value. So table value for chi-square. Here the level of significance is not yet mentioned, therefore we'll take the default level of significance, and the default level of significance is 5%, and the degrees of freedom will be n minus 2. That is the number of here n denote the number of observed frequencies and expected frequencies which involved in the calculation of pi square, and the number of frequencies which are involved in the calculation of pi square will be 4. 1, 2, 3, 4. So here it will be 4. So table value will be chi square, and a 5% that is 0.05 comma 4 minus 2, the value is that is chi square 0.05, sorry, 0.05 comma 2 is 5.99. So, next finally is the hypothesis, that is your H naught, that is the observed frequencies fit with the binomial distribution, fit with the binomial distribution, and your alternate hypothesis H1 will be negation of that, that is the observed frequency does not fit with the binomial distribution. Here the calculated value of chi square CV, you know the calculated value of chi square, which is equal to 6 point, I'll check it, 6.39, whereas table value of chi square for 5%, and then degrees of freedom is 2, which is equal to 5.99, right? Yeah, 5.99. Okay, which is not smaller, therefore H naught is rejected, that is H1 is accepted, that is the conclusion is the observed frequencies, that is observed frequencies, that is the given frequencies does not fit with the binomial, does not fit with the binomial distribution. Yeah, one second I revise it, listen. So your question is, we want to fit a binomial distribution. Once after fitting, they have to test the goodness of fit using chi-square. And this is here given data. Okay, here the small n is 6 and the capital N is equal to sum of the frequencies, which is equal to 80. Okay. So the first step is we want to fit a binomial distribution. For that we want to compute the mean. Mean is equal to sigma fx divided by f. So here the sigma fx is 192 divided by 80. We got 2.4. Therefore the mean value is 2.4. We know that in binomial distribution mean is equal to np, which is equal to 2.4, and from the data we got that the small n value will be 6. So substituting the value of n is equal to 6, we get the value p is equal to 2 by 5, And also we know that in binomial distribution, p plus q is equal to 1. Therefore, q is equal to 1 minus p. So we get q is equal to 3 by 5. Then the corresponding binomial distribution is P of x is equal to x is equal to 6cx, 2 by 5 raised to the power x, and 3 by 5 raised to the power 6 minus x, where x takes the value 0, 1, 2, 3, 4, 5, and 6. Now we will compute the expected frequencies. The formula to compute the expected frequencies will be capital N, that is sum of the frequencies, into P of x is equal to x. So 80 into P 6cx, 2 by 5 raised to the power x, into 3 by 5 raised to the power 6 minus x, where x is equal to 0, 1, 2, 3, 4, 5, 6. So substituting the values for x is equal to 0, 1, 2, 3, 4, 5, and 6, and round up the values, we will get the expected frequencies are 4, 15, 25, 22, 11, 3, and 0. And the sum is 80. Okay, we can cross check it. Now, to check the goodness of it, we are going to use the chi-square distribution. For using the chi-square distribution, the frequency's value should be greater than or equal to 10. So here, if you see the frequency 5, that should be clubbed with the nearest frequency 18, we will get 23. Correspondingly, we have to club their expected frequencies. So 15 plus 14 is equal to 19. Here both 23 and 19s are in greater than 10. Next, if we go for the last one, we will get the frequency will be 64. If we had, I will get 10 here. But even though the other side, if you club, expected frequency will get 3 plus 0 is equal to 3. Still it is smaller than 10. Again we have to club with the neighbor frequency. So we will get 11 plus 3 is equal to 14. Correspondingly, we have to club with the neighbor frequency for the observed frequencies. We get 10 plus 7 is equal to 17. Therefore, the number of observed frequencies and expected frequencies have now become 4, and their corresponding values are 23, 28, 12, and 17 for observed, and the corresponding expected frequencies are 19, 25, 22, and 14. Next, we have to compute the value of chi-square. The formula for computing the chi-square will be summation of I OI minus EI the whole square divided by EI. So if you do that one, we will get 23 minus 19 the whole square by 19 plus 28 minus 25 the whole square by 25 plus 12 minus 22 the whole square by 22 plus 17 minus 14 the whole square by 14. So if you simplify this, you will get the calculated value as 6.39. Similarly, we want to find the table value to check the to do the conclusion part. So chi square, the default level of significance is 5%, and the degrees of freedom is n minus 2. Here the n will denote the number of observed frequency, is not the small n values for the binomial distribution. Here you have to be more careful. So we get the n value will be 4 here. So that is number of observed or expected frequencies. 4 minus 2 is equal to 2. So chi-square value for 0.05 and 2 in the table, I got it at 5.99. Now we'll set the hypothesis. Here the hypothesis are observed frequencies are fit with the binomial distribution, whereas H1 will denote the observed frequencies are does not fit with the binomial distribution. Now we have to go for the conclusion. That is the calculated value of the chi-square. Here I got it as 6.39, whereas the table value for the chi-square for 5% and the degrees of freedom 2 is 5.99, and that is not calculated value is not smaller than the table value. So as per the thing, the H0 will be rejected, that is H1 is accepted. That is your final conclusion is the observed frequency, that is the given frequencies does not fit with the binomial distribution. Thank you.